Welcome back. Today we're going to talk about magnetic and electric fields. We're going to discuss how a magnetic field can be modelled using the Aether superfluid model, that we have an ether of fluid, and that's what causes magnetism. We're going to look at how magnetism and electricity are related to each other and how the Aether superfluid model can demonstrate this. We're going to have a look at electric charges and electric fields and what happens when you stress a medium too far and get an dielectric breakdown. We're then going to bring this all back and talk about our torus and how electricity and magnetism relate to our ether whirlwind structures. Hello and welcome back. Today I want to talk about my understanding of how magnetic fields and electric fields work, together with the understanding of how a whirlwind works. Understanding the ether fluid model of magnetism really nailed this for me and gave me an understanding of how this can work. We're here at the Bay of Fires in Tasmania, a beautiful location with these red rocks, beautiful white sand beaches. But honestly, I'm more interested in these rocks. To me, they look like a quartz conglomerate rock, which is a piezoelectric crystal, the quartz. It's the same sort of crystal that is used in the ultrasonic cavitation cleaner. When a charge is applied to it, it generates a force. Now that also works the other way around. As we can see from a barbecue lighter, when we light that, what starts that ignition is there's a little piezo quartz in here. And when it's squeezed, it generates the spark that can ignite the lighter. I had another one of these, again, it broke, so I pulled it apart. This is the little mechanism in here. I might show you a close-up of that. But inside there's just a little spring and a little hammer. And that hammer then strikes a little slice of piezoelectric crystal. And that force is enough to make a spark between the wires. And that can ignite the flame. So for me, looking at what we've got here, we've got lots of moving water, we've got piezoelectric crystal rocks. I reckon this could be a great natural habitat for natural plasmoids to form. In my travels, I've gone filming nature, and I believe I've found some natural plasmoids, and I've got footage of them, and I'm looking forward to sharing that with you later. All right, so let's talk about magnets. Got a couple of magnets here. And I think magnets are really cool, and we take them for granted. We don't really think too much about how they work, but they sure do. There's a invisible force that can travel through our body. We can't see it, but we obviously know it's there. So how does magnetism work? Yeah, mate, they're magnetic. Yeah, but how does the magnetism work? You know, one side attracts, the other side repels. But what causes it? It's magnetism, mate. No, anyway, have you got what you need? Because I'm going to go fishing. Yeah, thanks, mate. Righto. Don't forget to like and subscribe. And I never really dive deeper than that into how magnetism works, to be honest. You just take it for granted. I'm sure we've all seen those pictures of the iron filings around a magnet, or maybe a ferrocell that shows the magnetic field lines around. What we're actually seeing there is the slice of a torus. When we see those magnetic field lines, we are seeing a slice of a torus with the north and the south poles there. So this shows the magnetic field lines, but what's causing it? And why are some materials magnetic and some aren't magnetic? If we assume the fluid ether model, we can demonstrate magnetism using another fluid, water. What was really a game changer for me was when I found this video from the Fractal Woman, who references Yonel Dinu's work, where he has demonstrated magnetism in water. So we're going to have a look at that now.
This experiment was done by an independent researcher, Lionel Deneu. Now it's going to be hard to see in the video, but they are spinning in opposite directions. So they're spinning and spinning up the water, and now they are attracting to each other and sticking to each other. So in this experiment, instead of spinning the cylinders in opposite directions, he's spinning the cylinders in the same direction. So let's have a look at that. So they're both, it looks like they're both spinning clockwise. And now they seem to be repelling each other. The distance between the cylinders is increasing. So he's trying to push them together, but they're not coming together.
In this example, he set up longitudinally rotating tubes with different colours on each end to represent north and south, and we can see examples of attraction and repulsion modelled in the water again.
And so what we're seeing there is a fluid dynamic process. If you're familiar with fluids at all, there's a theory called Bernoulli's theory, which says that when a fluid flows faster, it creates a low pressure zone. This is the principle for aeroplane wings. The air fluid flows faster over the top of the wing, creates lower pressure above the wing. And we can also see Bernoulli's theorem through these Venturi type systems where the smaller section means the fluid has to travel faster and generates a low pressure zone. Similarly, as we just saw in those magnetism examples in the water, the rotating cylinders would draw the water through, moving it faster, creating a low pressure environment. I believe that is a perfect analogy for what we're seeing in the ether. We are creating a flow around a magnet of this ether superfluid. So if we imagine our magnet's field around it as a flowing torus, we can see we will have a vortex type structure at the top coming out, a corresponding vortex structure at the bottom going in, and down the sides we have this diagonal sideways movement. Now you can imagine if we put two of these together and they were going in opposite directions, they're going to push themselves apart, as we see with a magnet repelling. Or if we have two going the same way, so we have a spiral going in and a spiral going out, they're going to help each other and join together and make one larger magnetic field. I believe that's what we are seeing with magnetism. It's the flow of the ether superfluid around it. To me, this makes a lot of sense. So why are certain materials magnetic and some materials are not magnetic? We've got a couple of magnets here. We've got some magnetite, or the old name for this was lodestone, and a couple of little neodymium magnets. The neodymium's a lot stronger, as you probably know. So what is it in this metal, in this magnetite, that is generating a magnetic field? Well, at an atomic level, I believe these atoms are an ether pump, and I'll explain. So when we make an electromagnet, we coil a wire, typically around an iron core or something similar. We have a coil of wire, and we pass an electric charge through that wire, and that induces a magnetic field around that coil. In physics, we have what's called the right-hand curl rule, which tells me if I curl the electrical charge in a certain direction, I would generate a magnetic field in that direction. We can see that from this coil. And I have an example here I've quickly wrapped a bit of wire around a screw, attach a charge, and we can see from the compass we're generating a magnetic field. And if I swap that charge around, I can make the magnetic field go the other way. So how does that relate back to our natural magnets, our magnetite and our neodymium? Well, what's special about these materials is they have an unpaired electron. So most of the electrons are a balanced charge and they cancel out. But in these materials, they have an unpaired electron, so it has a freely circulating, electrically charged particle. Now, as we've just seen from our coil example, if we curl an electric charge, we will generate a magnetic field. So the atoms in our magnetite, or neodymium, are curling an electric charge and generating a magnetic field. I believe these are, in essence, little ether pumps continuously whirring at the speed of the atom, generating that superfluid flow. In order to demonstrate a bit further what I'm talking about for a superfluid flow, I've got a little bit of footage here of a superfluid that people have made, and that is cooling helium down as low a temperature as possible. And helium becomes a superfluid and has these strange characteristics. One of those strange characteristics is, they say, frictionless flow. And if you start a fountain or a toroidal flow pattern, it will keep going. So if we can see that helium, liquid helium, this supercooled helium, is a superfluid, if we have an ether superfluid, I believe we can apply that model here too. And we will have a frictionless flow of ether superfluid that is causing magnetism. For me, joining those things together and seeing the ether as a liquid flow that causes magnetism, together with the idea of whirlwinds, really nailed down to me how this process works. So hopefully I've shown you how magnetism can be explained by an ether superfluid model. Another important aspect we're going to be talking about today is electricity. So I'm going to start with how electricity and magnetism are intrinsically linked. You can cause one with the other and vice versa. I'm going to demonstrate to you again how this ether superfluid model can apply to this electromagnetic effect. Here I've set up another simple experiment where I've got a magnetic field from my magnets and I've placed a bare wire within that field. In essence, I have a stream of magnetic fluid flowing past this wire. When I apply a charge to that wire, we generate a force and we can see the wire move. In physics, we have another right-hand rule. Different to the right-hand curl rule, this is a right-hand rule about electromagnetism. This tells us if we have a magnetic field in one direction, we have an electric charge in another direction, we will generate a force perpendicular, all at 90-degree angles to each other. And we can see that demonstrated here. I have the magnetic field flowing this way, I have the electrical charge flowing this way, and the wire is forced that way. Now this also works in reverse. Instead of generating a force, if I apply a force to the wire in a magnetic field, I can generate an electric current. I've demonstrated that here again. I've just used my same coil of wire and I'm passing it through a magnetic field. Now, I'm not working with high strength magnets or good setup here, but we can demonstrate the principle. In this example, I had to move it back and forth fairly fast to generate the mighty 0.002 volts you see there. But again, we're just demonstrating the principle here. I'd say the majority of our electricity we use is generated using this method, passing a conductor through an electric field in the form of a generator. So wind energy spinning a turbine, a coal power plant generating steam to drive a turbine, a nuclear power plant generating steam to drive a turbine. Most of our power is generated this way. Now, if we go back to this example of the wire in the magnetic field, it's not until an electric charge is applied to that wire that it becomes visible to the magnetic field. It is essentially invisible to the magnetic field until there is electricity in action. At the point at which electricity is passed through this wire, a force is generated. And the direction of the force depends on the direction of the magnetic field and the direction of the electricity. I'm going to show you how we can apply the ether superfluid model to this action as well. If we imagine a stream of running water and we place our paddle into this stream, we angle the paddle perpendicular to the stream, there's not going to be much force on this paddle. It's essentially invisible to the stream. If we then apply a charge to this conductor or our paddle by twisting it, we generate a force. And the direction of that force depends on the direction we have twisted our paddle, or the direction of electricity that we've placed through our conductor. So that was an overview of my understanding of how the ether superfluid model can apply to magnetism and magnetic fields. The other field we want to talk about today is electric fields. And for me, the best way to understand or think about electric fields is with a plate capacitor. A plate capacitor, as the name suggests, is two conductive plates spaced apart to form a capacitor. Now, we use these in all our electronics to store electricity in the space between the conductors. Now, that space between the conductors is called a dielectric. It's a non-conducting material. That can be air, that can be plastic, that can be wood. So what happens when we apply a charge to these plates is we store a charge in the electric field. That can then be discharged rapidly because the dielectric material wants to return to its original state and deliver that energy back out of the system. I imagine the charge on this dielectric material as a stress on the fluid medium or the dielectric material in between. So if we have our atoms that are in that dielectric material, say they look like this, and they have electrons spinning around as they do, and we apply the electric charge, I imagine we are stressing, we're placing a strain on those electrons. Now we can only strain that to a certain point before an electron will break free and start to travel. That free electron will ionize that material and create a highly conductive channel to make a discharge between those plates, and we lose our stored energy. That's a spark discharge or dielectric breakdown. One of the best natural examples we can see of this is lightning. We essentially have the Earth as one plate of the capacitor, the cloud bank as another plate of the capacitor. The charges build to a point until we get that dielectric breakdown of the atmosphere in the form of lightning. So we've covered the superfluid magnetic model, how an electric field might work, and we spoke about our right-hand rules that we have in physics, the right-hand curl rule, where if we apply an electric charge in a curl, we will generate a magnetic field. Similarly, we can apply a force to a conductor in a magnetic field and create electricity. These things are intrinsically linked. Magnetism can cause electricity, and electricity can cause magnetism. To bring that back to our ether whirlwind torus model, we're going to be talking about plasma. We need a plasma torus. You may have heard plasma is the fourth state of matter. We have a solid, liquid, gas, and then above gas we have a plasma. What's special about a plasma is the atoms have been disassociated. The charges of the atom have become disassociated. There's free electrons and free protons. They are not necessarily bound to each other. They're free to move. So we have got independent charged particles free to move. When we create that torus structure, or that whirlwind, out of plasma, we can imagine one of these charged particles inside here. He's spinning around inside the torus, inside this plasma smoke ring. Now, if we apply our right-hand curl rule to that situation, we can see that if he's spinning around that way, he's going to be generating a magnetic field, a closed loop magnetic field within the torus. So we have a moving electrical charge and it's generating a closed loop magnetic field. We can now use our other right-hand rule where we have a magnetic field, force, and electric charge. If we have our charged particle, he has an electric charge and he's moving in a magnetic field, he will be generating a force. And as it moves around the different stages of circulation, that force will always be pointing back to the center of that magnetic field. So we have like a centrifugal force going on there, a self-reinforcing system. The faster this particle goes, the more magnetic field it will generate. In turn, the more magnetic field it generates, the faster it will circulate. And that is why this torus structure can have such great stability. It's a self-reinforcing electromagnetic system. There's something else quite special about these structures in terms of magnetism. We can see from this research paper here they've modelled a plasma torus and the magnetic fields that it has generated. They've determined the strength of those magnetic fields. Now, for reference, there's another Veritasium video where he's playing with the world's strongest magnet. That strongest magnet is 45 Tesla. That's a very strong magnet. This paper is showing us that inside a plasma torus, it can generate magnetic field strengths of over 1,000 Tesla. This is an extreme environment inside this torus. And that's partly what allows it to perform these magic functions of jamming molecules together to do cold fusion and other things. So what are our key takeaways here? Well, we said a magnetic field can be modelled with an ether superfluid flow. Electricity can induce magnetism, and magnetism can induce electricity. These two things are intrinsically linked. Together, electricity and magnetism work in a plasma torus structure to create a self-reinforcing system to create the stable torus. So for this cavitation session, I thought I'd run through how I got from ultra experiment to where I'm at now. When I decided to get into it, I ordered the ultrasonic jewelry cleaner. While I was waiting for that to arrive, I downloaded and got my hands on everything I could related to ultra and cavitation, and just watched and consumed everything I could. It might sound a bit boring to you, but honestly, after getting into this, there is nothing more interesting to watch. No Netflix, no footy. It's only this now, that's all I do. But there's nothing more interesting in the world. But we need to be careful where we go, because this rabbit hole is big. That's why I made the 10 steps to the ether. If we follow the plan, we'll be safe. Because if we deviate from the plan, we can get lost in this rabbit hole, that's for sure. So come with me on the 10 steps to the ether and we'll get there. So I learned all I could about the ultra experiment, but it was this video from Bob called Making Sprites that really, I saw something interesting in there. When I went through this video, something caught my eye, and I went through frame by frame and I saw this faint torus structure there. What I think we're seeing there is basically a dying torus. It's something had formed, and that was what we're seeing as the remnants of the dying torus. But that got me thinking, we could make wheels in water. And what if we could do that process in reverse? And instead of having a dying torus exploding and dying, what if we could build it from the outside in? So when my machine arrived, I very excitedly started trying to make the sprites and replicate what I'd seen. But all I could see was these little tornado type structures, and I tried different things. I tried filming it under plastic to get a better view at it, but I never achieved what I was seeing in that Making Sprites video. Now, the little tornadoes were cool and I liked watching them, but I really wanted to see something more. So I just started experimenting with different things, different materials, different shapes, just having a crack, seeing what worked and what didn't. And these next set of videos will run through, this was the day that it all sort of changed for me. The first thing I did here was I just had a piece of aluminium I'd cut out of a can, put it under a glass jar just to get a look at it and really get some intense cavitation under there, see what was going on. And then after that, I just put a can in there and sort of equalised the water levels and watched what happened. And I remember when I was watching it, I could almost see like something in the water moving spinning around, and I thought that was a bit interesting, and again just kept going with it. Tried a few different setups in there, and I remember seeing when I was watching it, little sort of, they look like the little whirlpool type structures coming in. And that was all I could see, just these little whirlpools moving across the water, and I thought that was cool. But it wasn't until later when I reviewed the footage that I saw this really interesting action. I don't even know what to call it. Are they little underwater plasma orbs, little cavitation orbs forming and sort of gathering and collecting into the system? And that's when I thought, yeah, we've got something here, and it's pretty exciting. So I thought I'd run you through my typical sort of setup of how it looks. I sort of copied Bob's setup for his Making Sprites video, where we have our ultrasonic cleaner, have a torch, and we're shining in there just to get a bit of light. I've also been playing around with a infrared torch as well. I think that's what we're looking at here is definitely some infrared action. That's why the camera sees it, but our eyeballs don't. And then we have our camera set up on a little tripod over the top. Important to set that highest resolution, highest frame rate you can, you know, ideally using a better camera than a camera phone, but we work with what we got. And then experimenting with different shapes, you know, regular foil, different cans, you know, maybe put a hole in it. This one I put a hole in the bottom. I think with the cans, when you put them in, it's important to try and get rid of the air bubble in there, try and make it so it's all full of water. Even tried some steel cans just to see what the effect of that was. Another pro tip I've found is to use a little syringe so we can take out a little bit of water or add a little bit of water as need, so we can adjust the water level and get it tuned just right and maximize those resonant nodes within the ultrasonic cleaner. But I mean, that's basically it. Obviously water as well, and just see what you get. This episode's shout out, I want to shout out the Fractal Woman on YouTube. After watching Bob's stuff for a long time, I found the Fractal Woman on YouTube, and she's doing some really interesting things. For me, it was her videos on magnetism and her modelling of electricity and the ether were really opened my mind to what's going on here. She also referenced Yonol Deneu's work. I've had a look at his channel. He, again, looks like he's into some really interesting stuff. It looks like there's some people who are building up computational fluid dynamic models of the ether. And I really think that could be an area of engineering investigation if we adopt this fluid model of the ether, and then we can develop computer programs to model it, as we do with aeroplanes and other aerodynamic things. We might really be able to understand and engineer this technology further. So, thanks to the Fractal Woman, and thanks to Yonol Deneu. Well, that brings us to the end of episode 2 with magnetism and electric fields. Again, thanks for watching. I've been really chuffed with the response to my first video. It looks like there's a thirst for this kind of explanation of things, and I'm glad I'm able to fill that need and help some people out. Last week I felt like we ended a little bit abruptly, so I've decided we needed a song to take us out. I prompted an AI to make us a song. I've added a few images from the stuff I've seen in the Cavitator. So I hope you all enjoy the world premiere of Vortex of the Ether. Rotas!
Spinning in the ether where the plasma glows. Summon up the whirlwinds as the cosmic force flows. With creator's power in the realms unseen. Harmony with nature is the ultimate dream. Feel the pulse of starlight as it warps the sky. Whispers of the cosmos in the wink of an eye. Electrons dancing in a wild embrace. A whirlwind of ether leaves without a trace. We are the children of the plasma tides, riding on the currents where the stardust glides. Harmony with nature echoing through the night, in the vortex of creation where the worlds unite. An energy infused in every breath we take. Whirlwinds of the ether make the fabric quake. Creator's own rhythm in the heart of time. Nature's song composing in a cosmic rhyme. Gather all the forces from the galaxy seam. Plasma waves and whirlwinds fueling every dream. In the dance of elements, the truth we find. Unity with nature is the ultimate dream. We are the children of the plasma tides, riding on the currents where the stardust glides. Harmony with nature echoing through the night, in the vortex of creation where the worlds unite.